Ever play a game where the enemies seem to be out to get you? Like they're making smart decisions on the fly.
Yeah.
That's the magic of game AI we're diving into today.
Okay.
Specifically, how it works in Unity.
Okay.
And to help us with this, we have this book, Beginning Game AI with Unity.
Great book.
It's kind of mind-blowing when you think about those old Pac-Man ghosts, right?
Yeah.
Back then, that felt revolutionary. But this book breaks down how we can create that same feeling of believable behavior
Right.
in our own games.
It's really cool. What's fascinating is that game AI is often about creating an illusion.
Okay.
It's not always about true intelligence,
Right.
but rather making the player believe they're facing a thinking opponent.
So tricking the player,
Yeah.
basically. I'm into it. But where do we even begin?
Well, the book starts with the fundamentals, like defining what game AI actually is.
Okay.
You know, it's easy to oversimplify it as just making things move,
Right.
but it's more about crafting the perception of intelligence,
Okay.
making those in-game entities act like they're making decisions.
Okay, that makes sense.
Yeah.
And to do that, I imagine we need to understand how games work on a deeper level, which is where this whole, like, vectors thing comes in, right?
Absolutely, yeah.
I'll be honest, that's always been a bit of a head-scratcher for me.
Yeah, vectors are crucial in game development. Think of them as the language of motion and position within the game world.
Okay.
Instead of just points on a graph,
Yeah.
they represent both a location and the direction.
Okay, so less like a dot on a map and more like telling someone to walk 3 steps north.
Exactly.
Like it's a direction and a distance combined.
Exactly. The book uses the analogy of a joystick to illustrate this. And that input from the joysticks, that's basically a vector in action, telling your character where to go and how fast.
Okay.
And this applies whether it's a classic 2D game or a modern 3D environment.
That actually makes a ton of sense.
Yeah.
So we've got our heads around vectors,
Okay.
but how do we actually put them to use? The book jumps right into building an intelligent cube. And before you ask, I know, no fancy graphics here.
Yeah. Think of it as a bare-bones starting point.
Okay.
We use a simple cube in a 3D space to understand the core mechanics of movement before things get more complex.
Okay.
It's all about learning the fundamentals.
So it's like starting with stick figures before you can draw a whole masterpiece.
Exactly. And this is where we see those vectors in action. You learn to make that cube move smoothly towards a specific point, any point you click.
Okay.
Imagine the strategic movement you see in a real-time strategy game,
Right.
but with our little cube as the star.
That's cool. So how do we keep our cube from moving like it's stuck in an old stop-motion film?
That's where steering behaviors come in. We delve into how to make our cube rotate realistically as it moves, making its actions feel smoother and less robotic.
Okay, so our cube is moving gracefully, but games are rarely wide-open spaces. We need mazes, obstacles, challenges, and that, my friend, is where this whole waypoint thing comes in.
Precisely. Imagine dropping breadcrumbs for your character to follow. That's the basic idea behind waypoints.
Right.
They allow us to create paths, even really intricate ones, to guide our AI.
So we're laying down a track for our cube, but using code instead of, like, actual breadcrumbs.
Exactly.
I like it. And the book takes this even further by having us build a whole labyrinth for the cube to navigate.
Exactly. And to do that effectively, we need more than just trial and error.
Right.
The book dives into actual pathfinding algorithms, and the first one we encounter is breadth first search, or BFS.
Breadth first search. Sounds intense.
It's actually quite intuitive when you break it down. Imagine you're searching for a specific item in a messy drawer.
Okay.
With BFS, you'd systematically check every single item, one by one, until you find what you're looking for. It's like a methodical treasure hunt.
So it guarantees you'll find the shortest path, but it might take a while if your drawer is really messy.
Exactly. And in a game, that messy drawer is our maze. BFS will always find a path to the exit,
Right.
but it might not be the most efficient if there are a lot of twists and turns. Think about classic Pac-Man. Those ghosts aren't exactly known for their clever routes.
That's a good point. Sometimes the most direct route isn't the smartest, especially if you're trying to avoid, those pesky ghosts.
Exactly. And that's where the concept of weighted graphs comes in. Imagine a map with different types of terrain.
Okay.
Some paths might be flat and easy to traverse, while others are mountainous and treacherous.
Okay, so like the shortest path on the map might actually take you longer because it's full of obstacles.
Precisely. In a weighted graph, we assign costs to different paths to represent those challenges. It's about finding the optimal balance between distance and difficulty.
That makes a lot of sense. But how do we actually translate that idea of weighted graphs into our game world, in Unity?
That's where NavMesh comes in. Think of it as baking a navigation surface onto your game environment,
Okay.
taking into account those weighted costs we talked about.
Okay.
Imagine pouring batter onto a cake pan.
Okay.
The pan is our game world, the batter is the NavMesh, and the obstacles in the pan influence the shape and texture of the final cake.
That's a surprisingly delicious analogy.
Yeah.
So we've baked our nav mesh with all its twists, turns, and weighted paths. How do we actually get our AI to use it effectively?
That's where A comes in our superstar algorithm.
Okay.
It's like BFS, but with a turbo boost of intelligence.
Oh, yeah, I like it.
It uses a heuristic, which is just a fancy word for a rule of thumb to make smarter guesses about the best path to take.
So instead of blindly checking every possible route, it's like our AI has a sense of direction and can make more educated guesses about which paths are worth exploring.
Exactly. A is all about finding the optimal path based on factors like distance, cost, and even potential obstacles. It's like having a built-in GPS for your game characters.
Okay, I'm really starting to see how all of this comes together. We've got our characters moving smoothly with vectors, we're using waypoints to create paths, and we've got these sophisticated algorithms like A to navigate complex environments. But all this talk about movement and algorithms, it's time to see these concepts in action.
You read my mind. That's where our stealth game comes in.
Okay.
We're taking all these tools and techniques and using them to create a more engaging and believable gameplay experience.
This is where things get really exciting. We're finally going to breathe some life into our AI and make them act with a purpose.
Exactly. We start by giving our guard character a specific goal
Okay.
to patrol the area and keep an eye out for the player. It seems simple, but this is the foundation for all those tense stealth moments.
And of course, no stealth game is complete without the element of sight, right? We need to define what our guard can and can't see. Enter the field of view, or FOV.
Precisely. The FOV is essentially a cone-shaped area around the guard's head that determines what they can see. Anything within that cone is visible to them, and anything outside of it is hidden. It's like their own personal spotlight of awareness. And it's a crucial element in creating those heart-pounding moments where you're trying to stay out of sight. It's like that moment in a horror movie when the character walks past a doorway and you're just waiting for the jump scare.
Yeah.
That's the power of FOV in action.
Okay, I can totally see that. But just being able to move and see isn't enough to make our guard truly believable, right?
Yeah.
We need to give them some more complex behaviors.
Absolutely. That's where finite state machines, or FSMs, come into play. Imagine a flowchart that dictates an entity's actions based on its current state and any external triggers. That's essentially what an FSM is.
So instead of just wandering around aimlessly, we can give our guard a set of instructions like, if you see the player, chase them. If you lose sight of them, investigate. And if there's nothing suspicious, just keep patrolling.
Exactly. And the beauty of FSMs is their modularity. We can easily add more states and transitions as our gameplay becomes more complex.
Right.
Remember that classic Metal Gear Solid trick of knocking on walls to distract guards?
Oh man, that brings back memories. Such a simple mechanic, but it added so much depth to this stealth gameplay.
Exactly. That's the power of a well-designed FSM.
Yeah.
That knocking sound acts as an external trigger,
Right.
interrupting the guard's current state and forcing them to investigate.
Okay.
The book actually walks us through implementing something similar.
Yeah.
And it's amazing to see how seemingly complex behaviors can be broken down into these logical, manageable chunks.
That's so cool. It really shows how game AI isn't just about creating super intelligent beings, but rather about crafting believable and engaging experiences for the player.
Precisely. And you know what's really fascinating?
What's that?
All these concepts we've been exploring, vectors, pathfinding, FSMs, they're not limited to games. They have real-world applications in robotics, AI development, all sorts of fields.
So this deep dive isn't just about making games. It's like a crash course in understanding how AI works in general.
Exactly. Gives you a framework for thinking about how these systems operate, how decisions are made, how behaviors are orchestrated, whether it's a character in a game or a robot navigating a warehouse.
That's incredible. This whole deep dive has been a serious eye-opener. And speaking of eye-opening, there's one final thought from the book that really blew my mind. This game called Creatures, where the AI could actually learn and pass on traits to its offspring.
Creatures was revolutionary for its time.
Yeah.
It explored the concept of artificial life, allowing AI creatures to evolve and adapt within a virtual environment.
It really makes you wonder, Could games actually hold the key to understanding the evolution of intelligence itself?
It's a question that sparks endless debate and fascination.
For sure.
But one thing's for sure, game AI has come a long way from those early days of Pac-Man, and who knows what amazing possibilities the future holds. One thing's for sure, the world of game AI is full of surprises just waiting to be explored. Maybe you'll be the one to create the next AI innovation that has players saying, "How did they do that?"